Greetings, this is Mr. Gordon here with page 1 of the Unit 3 test review. I hope you're having a nice spring break. It's 73 degrees here in Raleigh, um, and the captain has just turned off the fasten seatbelt sign, so enjoy the ride. As you guys can see here, I'm starting with problems 1, 2, and 3. The instructions for these problems are to solve each proportion. So when we have a proportion like this, little math 1 review, we want to cross multiply. So I cross multiply here, 5 times x, I get 5x. 20 times 4, I get 80. So now it's just a basic equation. Divide on both sides by 5, and I get x equals 16. Same thing in number 2. I cross multiply. 7 times 6 is 42. And 10 times x is 10x. So I can divide both sides by 10. And I get x equals 4.2. Then I cross multiply here. And I have to be careful because I'm multiplying 5 by the entire expression x minus 5. And on the other side, I'm multiplying 7 by the entire expression x plus 3. So this is going to be some fun math using the distributive property. 5x minus 25 equals distributive property again, 7x plus 21. Then I'm going to subtract 5x on both sides. And at the same time, well, I'll do it in one step, or 2 steps. Negative 25 equals 2x plus 21. Now subtract 21 from both sides. So I get negative 46 equals 2x. Divide both sides by 2. And I get that x is equal to negative 23. Now you may be wondering, why are these problems on here in a unit about similarity and congruence? Well, when we're using similar figures, a lot of times we're going to have to set up proportions, which we'll solve, and we'll have to use this process in order to complete it. So we'll start with the geometry, similar figures, end with the algebra, solving proportions by cross multiplying. So for example, in the next set of problems, it says the figures in each pair are similar. So remember, similar means two things happen. One, corresponding angles are congruent, and two, corresponding sides are proportional, or they have a constant ratio. So because corresponding sides have a constant ratio and corresponding angles are congruent, there's a lot of things I can do. For example, I'm going to use the fact that corresponding angles are congruent in this first part because x is a corresponding angle with this angle right here, so x equals 42 degrees. Now, y is a corresponding angle with this angle right here. So with a bit of work, we can figure out what that is. In any quadrilateral, you know it has to be 360 degrees. So let's look at this figure. We have 360, 90, and 90, so we subtract 180. So that's 180. And we subtract this angle over here, the 42. So that leaves me, goodness gracious, must be spring break. Can't do this math. 138 degrees for y. So y is 138 degrees. Again, that came from 360 minus 90 minus 90 minus 42 to get that. Let me just erase those marks so they don't confuse you. Finally, we want to use the fact that corresponding sides are in a constant ratio in order to solve for z. So z is a corresponding side with 12, so I'll say that z over 12 is equal to, and I can pick any other set of corresponding sides. I'll do 6 and 8 is equal to 6 over 8, which simplifies to 3/4. So now I cross multiply. 4 times z is 4z. 3 times 12 is 36. So 4z equals 36, which means dividing by 4 on both sides, z is equal to 9. So we have 42 degrees, 138 degrees for y, and z is 9. Which brings us on to number 5, which is just way easier of a problem. Started you off with a bear there. But the trick here is we have to think about the orientation. Notice that this one is in more of a vertical orientation as opposed to this rectangle, which is in a horizontal orientation. So x actually matches up with 2, while 8 corresponds with 4. So the proportion I can set up there is x over 2 equals 8 over 4. So then we cross multiply, or if you can just see from here that x is 4, that's great. But I'll cross multiply, so that's 4x equals 16. Divide by 4 on both sides, x is 4. Yay! And finally, we have x corresponds with this angle, so x is 63 degrees. Woo -woo. And now y corresponds with the 4, so y over 4 is equal to 16 over 8. Show you a different algebraic way to do this one. 16 divided by 8 is like 2 over 1. So that makes my cross multiplying a little easier. 1 times y is y. 4 times 2 is 8. So y equals 8. And x was 63 degrees. So that's how we get those. Now finishing off the page, the instructions for 7, 8, and 9 are the triangles similar? If yes, write a similarity statement and name the postulate or theorem you can use to prove the triangles are similar. If no, write not similar and explain your reasoning. Let's actually say if not, write not similar and explain your reasoning. Mr. Ziegler would be mad. But let's look at number 7. So again, in order for two figures to be similar, we said two things have to happen. Corresponding angles have to be congruent, and corresponding sides have to be proportional. So corresponding sides have the same ratio. That's the definition. But we learned several shortcuts in this unit. We learned the angle-angle similarity theorem, or postulate, side-angle-side similarity postulate, and side-side-side similarity postulate. So the angle-angle similarity postulate says if two angles of one triangle are congruent to two angles of another, then the triangles are similar. That's all we need. Side-angle-side says if two sides are proportional and the angle between them is congruent in one triangle, same in the other, and we have those pairs, then the triangles are similar. And side-side-side says if we have three pairs of sides that are in the same ratio, then the triangles are similar. So we're always talking about pairs. Angle angle means two pairs of angles. Side angle side means two pairs of sides, and the angle between them and side means two pairs of sides. I mean 3 pairs of sides, sorry. So if I look at number 7, I have 3 sides, which means I'm probably going to use side for number 7. But I need to make sure that all of these ratios are constant. So the question is 8 over 12 equal to 10 over 15? And is that equal to 10 over 15? Well, obviously 10 over 15 and 10 over 15 are equal. 8 over 12 is also 2/3. So because all of these things are 2/3, yay, the sides are proportional. So this is going to be a yes by side similarity. So to write the answer up here. And this is what your final, it says, your final answer would look like. It says write yes, or sorry, it says if yes, write a similarity statement. So I don't even actually have to write yes. So my similarity statement is triangle RPQ is similar to triangle WTV. And it says name the postulate or theorem you can use. So I'm going to say by side similarity. Very important to include that similarity symbol. So that's the first one. Now, in number 8, I have 2 pairs of sides and a pair of angles, so that seems like a good possibility for side angle side similarity. But first I need to check and see, is 12 over 14, these sides are corresponding sides, is that equal to 16 over 18? These sides are corresponding sides. 12 over 14, that simplifies to 6/7 16 over 18, that simplifies to 8/9. So these are not similar in number 8. Which leaves us number 9, which is the easiest one. I have one pair of angles that are congruent, and then two pairs of angles that are congruent. So that is going to be angle similarity. So that's a yes. I need to write my similarity statement. So if I start with triangle A, B, I said A, but I wrote E. If I start with triangle A, B, C, that's going to be similar to, I started with the 1 mark, went to the 2, and then the none. So I need to start with the 1, go to the 2, and then the no marking. So that's triangle F, D, E, to make sure that corresponding parts match up. Angle A matches up with angle F, A and F match up, and then B and D match up, C and E match up. So we're good to go. So that is triangle ABC is similar to triangle FDE by angle similarity. Thank you for watching this video of the test review, page 1. Again, I hope you're having just a fabulous spring break.